Let's take a look at the sum and difference identities for sine. We have sine of alpha plus beta equals sine of alpha times cosine beta plus cosine alpha times sine beta. And the next one, sine of alpha minus beta is equal to sine of alpha times cosine beta minus cosine alpha times sine beta. So just like we did with the sum and difference identities for for cosine, we want to look at how we can apply them for sine. So let's look at sine of 165 degrees. So 165 degrees is not an angle that I'm familiar with on the unit circle, but my goal is write this as the sine of two angles, either added or subtracted, that those individual angles I know something about. So why don't I use 45 degrees and 120 degrees, because I know both of those places on the unit circle. Okay, so 45 degrees I know is just my main angle, and that's root 2 over 2, root 2 over 2. And then 120 degrees, let's see, that's just 30 degrees past of vertical. And so that's just over a little, negative 1/2, up root 3 over 2, that longer length. Okay, so why did I do all that? Well, because 45 degrees will play the part of alpha and 120 degrees will play the part of beta. And I will use this top formula here. So I have alpha plus beta is on the inside, right? Those are these two. It's going to turn into this big old thing where I have sine of something times cosine of something plus cosine of something, sine of something. And I do alpha, beta, alpha, beta. Okay, so I do 45 degrees, 120 degrees, 45 degrees, 120 degrees. And now I need to just evaluate each of those. I already have my unit circle all queued up, so this should be pretty straightforward. So sine of 45 degrees, root 2 over 2, cosine of 120, use that x-coordinate, negative 1/2, plus cosine of 45 degrees is root 2 over 2, times sine of 120 degrees is the y-coordinate, root 3 over 2. Simplify, I get negative root 2 over 4 plus root 6 over 4. So I like to write this as root 6 minus root 2 all over 4. All right, one more. Let's try sine of 5 pi over 12. Sorry, sine of negative 5 pi over 12. So what do we get here? Well, we have to rewrite negative 5 pi over 12 as some sum or difference of angles that we know. And sometimes you just have to kind of play around with this a little bit to get it to work. So I might try something like, let's see, I know, say, 3 pi over 12 minus 8 pi over 12 would be like a good candidate because I know they at least subtract to be negative 5 pi over 12. But this only works if I know something about 3 pi over 12 and 8 pi over 12, say on my unit circle, I know those values. So let's look. 3 pi over 12, let's see, this is just pi over 4, that will work. And 8 pi over 12 is 2 pi over 3, and that will work as well. So I'm going to use these moving forward. Now, if that didn't work, and I go, wait a minute, I don't know anything about one of these, then I would just kind of start over and try to play around with a couple other ones. Okay, so doing that, I'm going to say this sine of negative 5 pi over 12 is the same as sine of, start with 3 pi over 12, since that's the smaller one, minus 8 pi over 12. So everything I've written so far is true. And then I'm going to rewrite the ones that are in terms of pi over 12 as just what I recognize them as. So in this case, pi over 4 minus 2 pi over 3. Okay, pi over 4, you're playing alpha, 2 pi over 3, you're playing beta, and this is the subtracting one. So what do I get here? I go up. Sine, cosine, cosine, sine. Okay. Sine, cosine, cosine, sine. And then I go up and I go, okay, subtraction is subtraction, and then it just goes alpha, beta, alpha, beta. Okay, so that means pi over 4, 2 pi over 3, pi over 4, 2 pi over 3. And if I want to or need to show my work, all that, I can get a little unit circle queued up for me. Let's see, I need pi over 4. That's that nice main diagonal. So root 2 over 2, root 2 over 2. and 2 pi over 3. Okay, that's the same as that 120. So this one would be negative 1/2 root 3 over 2. Okay, so I'm ready. Sine of pi over 4, root 2 over 2. Cosine of 2 pi over 3, take that x-coordinate, negative 1/2, minus cosine pi over 4, root 2 over 2, sine of 2 pi over 3, 3 over 2. Okay, and I end up with negative root 2 over 4 minus root 6 over 4. And so I could just write that as negative root 2 minus root 6 all over 4. All right, last one. This says, what if you're starting with something that looks like the right side of the equation, or these identities, instead of the left side? And like, could we still do something with this? Okay, so the first thing I would look at when I'm looking at one of these expressions, I'd go, well, can I just evaluate it? Like, what's cosine of 40? What's cosine of 80? Let's go. But 40 and 80 aren't these kind of nice angles that we know about on our unit circle. So instead, I'm going to have to think about this in terms of one of these sum or difference identities. So I want to go up and look, like, which one does this look like that I've seen? So let's see, cosine, cosine, sine, sine with a minus in it. So I go back up and see, what did I say? Cosine, cosine, sine, sine. So I got to go back up. It doesn't look like anything that I have here, but I do go back up here and it looks like this guy here. And so that's good. I go, okay, well, I've got cosine alpha, cosine beta, sine, sine with a minus in it, and then the cosine of alpha plus beta. So, all right, go back down. So what this is telling me by my formula is that this is really the cosine of 40 degrees plus 80 degrees. Okay, so I'm really just working backwards, okay? And so if I do that, then I go, wait a minute, I don't want to go backwards, right? Like I don't want to go this way where I break it up because I just came from there. So the way I want to go is putting it together. So that's 120 degrees. So that is cosine of 120 degrees. And on my unit circle, right, that's just negative 1/2.